Welcome back. Okay, let's jump right into this explainer, covering Clip 9 of the Shotcrete Inspector course. Today, we're unpacking an absolutely critical topic: rebound, overspray, and placement defects. Look, if you're gearing up for the ACI exam, or honestly, if you're just fascinated by how these massive concrete structures actually hold together in the real world, this is foundational stuff. We're going to look at exactly what goes wrong when spraying concrete, and more importantly, the crucial actions inspectors have to take before those mistakes literally get set in stone.
Right out of the gate, the source material drops this incredibly heavy truth. The most dangerous shotcrete defect is often the one that disappears before anyone documents it. I mean, think about the stakes there. Your window of opportunity as an inspector, it is incredibly brief. Once fresh shotcrete gets covered by another pass or troweled smooth by the crew, any errors are permanently locked inside. If a crew is moving fast, a critical placement defect can be completely buried in just a matter of minutes. So your role out there isn't just taking notes, it's about actively observing the placement to ensure absolutely nothing flawed gets intentionally or accidentally hidden away.
So, big exam alert here. If you're taking the test, you have to know the strict black and white difference between rebound and overspray. Rebound is, well, exactly what it sounds like. It's material that strikes the surface and physically bounces right off. Now, a little rebound? Totally normal, but it is absolutely not acceptable structural material because all the heavy, coarse aggregates bounce away, leaving behind this really weak, paste-heavy mix. If that falls behind the reinforcement and gets buried, boom, you've just created a major weak zone. Overspray, on the other hand, is shotcrete that accidentally coats adjacent areas like forms or exposed rebar. If that's allowed to harden, it completely ruins the bond for the next layer. The golden rule? Neither of these materials can ever just be buried in the work. Period.
Okay, so how do you actually spot the difference between good and bad practice out in the dirt? Good practice means you're seeing intentionally placed shotcrete that fully and completely wraps around the rebar, complete encapsulation. Bad practice, though, involves uncontrolled overspray and this extremely dangerous phenomenon called shadowing. The course uses a brilliant analogy for this. Imagine shining a flashlight directly at an object. It casts a dark, empty shadow right behind it, right? Well, the exact same thing happens with a stream of shotcrete. If the nozzleman has a bad angle, or just poor technique, the reinforcement literally blocks the material, leaving a structural shadow of empty space right where you need solid concrete.
And it's those poor practices that lead directly to our biggest hidden nightmares: sand lenses and voids. Now, a sand lens is exactly what you're probably picturing: a weak, sandy pocket trapped right inside the concrete. It's basically like a tiny, unwanted beach right where you need massive structural strength. This usually pops up because of poor water control, segregation, or pauses in placement where rebound was just left to settle. Voids, meanwhile, are just empty pockets of air. They love to hide out behind congested rebar, in tight corners, or near forms where rebound gets trapped. This is exactly why, as an inspector, you have to watch those high-risk locations like a hawk during the actual shooting process.
Now, what happens when fresh material has way too much water, or maybe it's just sprayed way too thick? Well, gravity always wins. The course maps out this fascinating, albeit terrifying, domino effect. The severity scales up super fast. It starts with sagging, just a slight, noticeable downward droop. But if that's ignored, it progresses to sloughing, where the material actually tears and shifts significantly. And the absolute worst-case scenario? A complete dropout. That's where the material just completely gives up, gravity takes the wheel, and it falls away entirely. The massive takeaway for you as an inspector here is simple. Crews cannot just spray more material over a sagging area to hide it. No way. The underlying cause has to be addressed, and that affected material has to be properly removed.
Let's run through a quick field scenario to test this out. Picture this. You're watching a crew shoot a heavily reinforced wall. You notice loose rebound piling up at the base, right between the front and rear rebar layers. Or maybe you see the front face of the reinforcing cage is just heavily coated with overspray from an earlier pass. What do you, the inspector, need to verify before work continues? Well, the mandatory action is clear. That loose rebound has got to be totally cleared out, and that coated reinforcement must be properly cleaned off before it's encapsulated. Now, crews might use compressed air to blast those areas clean, which is fine, but if they're constantly producing excessive rebound, they need to actually fix their technique, right? Not just endlessly blow the mess away.
All right, reality check time. Imagine a newly finished wall that looks incredibly smooth. It is perfectly troweled, just an absolute beauty on the surface. But a few days later, a core sample is taken, and it reveals a massive void hiding right behind the rebar. This drives home one of the most vital principles in the entire course. A smooth surface appearance absolutely does not prove internal quality. The exterior can easily be manipulated by a skilled crew to look totally flawless, completely masking shadows, sand lenses, and voids underneath. You simply cannot inspect shotcrete after the fact just by staring at a pretty finished face. You have to be there, boots on the ground, observing the active process.
So to cut through the absolute chaos of a busy job site, the source material gives us a really fantastic 4-step mental framework. Step 1, what should I see? Well, you should see controlled rebound, clean active surfaces, and complete encapsulation. Step 2, what am I actually seeing right now? Are there piles of rebound? Is the material sagging? Step 3, why does it matter? It matters because, as we've learned, visible defects rapidly become hidden internal failures. And finally, step 4, what action is required? You have to ensure the condition is corrected before it gets concealed. This framework really enforces the ultimate golden rule of shotcrete inspection. Do not allow a visible defect to become a hidden defect.
Let's lock this all in with the 3 key takeaways you need for the exam. First, rebound is not structural and can never be buried. Second, overspray actively ruins your bond. And third, shadowing and sagging are serious structural problems that require actual fixes, not just quick cover-ups. Your overarching field takeaway for today? Act while the problem is visible. If you can still see the defect, you still have the power to stop it from compromising the entire structure. Which leaves me with a final thought for you to chew on next time you're on site. Are you just looking at the surface, or are you actually observing a structure being built? Think about that. Up next in Clip 10, we'll be diving deep into layers and construction joints. We'll see you there.